Hi all, in lesson 3 we're going to be talking about our x and our y intercepts, and your learning target is that you will be able to identify these things, the x and y intercepts, from graphs, equations, and tables. So when we're talking about linear equations and we're talking about these things called intercepts, what we mean is all of our linear equations are going to be lines. So let's imagine this line. And the intercepts are the points where this line crosses our x and y axes. So for this line I just drew, we would say that our y-intercept is right here and our x-intercept is right here. Let me get those labeled. And in a very, very general sense, we would say that your y-intercept is where your x is 0. And you can see that because if you follow your x-axis, here's where x would be 0. And so your y-intercept is when x has no value. So we would call that 0, comma, y is where your y-intercept would line. And then your x-axis, same thing. Here is the origin, or where y is 0, and then your x-axis crosses where y has 0 as a value, so that would be x, comma, 0. It can be a little bit confusing to remember those because what intercept you cross, the opposite coordinate is 0. Let's check out how this actually works with a linear equation. So we are being asked to find the intercepts of the equation, and we will use those intercepts to graph the equation on the coordinate plane. All right, and let's start with our x-intercept. So since our x-intercept is where y equals 0, we can rewrite this function of 3x minus 4y equals 12, and we'll replace y with 0. So it'll be 3x minus 4 groups of 0 equals 12, and then we can just simplify. So that is 3x, negative 4 times 0 is just 0, so 3x equals 12, divide both sides by 3, and we have x equals 4. And so what that means is since we have y equals 0 and x equals 4, that means that gives us the coordinate point 4, comma 0. So our x-intercept is at the point 4, comma 0, and then we can graph it. So here's where x is 4 and y is 0, and there is our x-intercept. All right, so let's calculate our y-intercept. And since the y-intercept is where x equals 0, we're going to do the exact same process, only this time for our function, we will be replacing x with 0. Okay, so there's our original function. I'm going to rewrite it as 3 times 0 minus 4y equals 12. 3 times 0 is just 0, so that leaves us with a negative 4y equals 12. Divide both sides by negative 4. And that leaves us with y equals negative 3. So then we now know that when x is 0, y is negative 3, and we have our y-intercept. Go where x is 0, y is negative 3, and we can label it. And all you really need to graph a linear function is 2 points. So once you have those intercepts, you can go ahead and connect them with a line. And don't forget, pop arrows at the end of our lines. That helps us see that this function will go on into infinity. There are infinite solutions to it, so we want those arrows on the end. All right. Here's a you try it with calculating your intercepts and then graphing them. So use that same process, pause this video, come back and see how you did. Okay, here's my work for the x-intercept. So when we make y 0, I ended up with an x as 3 halves, or you can just write that x equals 1.5 if that feels better for you. Go ahead and graph it. at the point 1.5 comma 0, and that is right about here. All right, checking on the y's. Okay, for the y-intercept, I end up when x is 0, y is 3, which gives us that coordinate point, 0, 3 for our y-intercept, and we can graph it right there. Okay, now we have those points. Go ahead and get out a ruler, make a nice crisp line between our two intercepts. That's not perfect, but close enough. And then we pop arrows on the end, and we're good. And before we dig into our notes here, I made an error. I would like you guys to go ahead in your notes and cross out proportional right there. And instead, we're going to write consistent. Sorry about that typo. Okay, so we can also find x and y intercepts using tables of linear functions. So here we have an xy table, and we are asked, following table represents some inputs and outputs of a linear function, and we are needing to determine the x and y intercepts of the function. Now, the best thing to do is just see if you have any x and y values for 0. Those would be given intercepts. And if they are, you don't even have to do any math. So, for example, right here, we see where y is 0. And we know that when y is 0, that is our x-intercept. All right, so since there's no need to calculate, we feel happy, and we can just say that our x-intercept, so our x-intercept is 4, 0. Okay, we do not have a place here where x equals 0, so we are going to have to calculate our y-intercept. So to do that, we want to look at our change in x values and our change in y values. And how we do this is just by drawing. So we know that from -1 to 2, what is happening is we are adding 3, and when we added 3 over there, what happened to our y values is they decreased by 1.5. Okay, right here, when it increases by 2, we see that our y values decrease by 1. And right here, we see that when it increases by 1, our y value is decreasing by 0.5. So even though these aren't, like 3 is not 2, is not 1, -1.5 is not, that should be a -1, is not -0.5, but there is a consistent rate of change here. So what we want to look at is, let's just start with this first grouping. So let's start with looking at these pairs. And we're going to use a new symbol right now. It's a triangle. It's a delta is what it's called. And what it means is change. And so we're going to say, how are your x values changing? Well, our x values are, in this case, we would say a change of 3. And our y values in these cases is a change in -1.5. And so in order to calculate the change that is happening here, we would want to say our change in y divided by our change in x is going to be consistent throughout this entire linear function. So here, for those two pairs, we'd say our -1.5 over 3. And we can use this rate to find a unit rate. So -1.5 divided by 3 is -0.5 over 1, which, strangely enough, is our change in y over change in x for these pairs. That is our base change. If we had also looked at these pairs right here, I just highlighted in green, we would have seen a change in x, or a change in y was -1. Our change in x was 2. And if we got the unit rate of that, that would be the same as saying -0.5 over 1, or just -0.5. So what this tells us is that when x increases by 1, y decreases by 0.5. And what we can do here, sorry, I'm going to shrink this down a little bit, is we can actually make a new table. Okay, so I just included where x is 0 on this table, and I'm going to fill in what I already know. I know that when x is 2, y is 1, but I also know that as x increases by 1, that y is going to decrease by 0.5. So that gives me right here, this is going to be 2. And we can double check. We can see what happens. That would mean that this would be 1.5, because as x increased by 1, y decreased by 0.5, and that pattern stays true. So what we have there is our y-intercept right here. So we would say that our y-intercept is the point where x is 0 and y is 2. Okay, I think these tables are pretty tricky, but you will start noticing patterns and it will get easier, but I do want you to do a you try it on this one. I recommend making another table that includes 0 so you can start to see how things are changing. All right, come on back and see how you did. Okay, so starting off, I found my rate of change and I saw that as y was decreasing by 6, x was increasing by 3, which gives me the rate of change of -2, which means that as x increases by 1, y decreases by 2. And so we can make another table that includes a 0. So 0, 1, 2, 3, and then let's just jump 4 in there. Plug in what we already know. We know that 1, it's 9. We know that 4, it's 3. And we know that as x increases by 1, y decreases by 2. So that must mean that right here, when we had an increase of 1, we can kind of work backwards there actually. Here, let me erase that. So that would mean the reverse is happening. I can actually pop this way and say, well, if I decrease by 1, then that means that this must increase by 2. So that would be 11, right? Because that would create some consistent growth, which would mean that 7, 6, 5, 4, 3, 2. Okay, cool. We are good to go here. We have a consistent pattern. As x is increasing by 1, y is decreasing by 2. And so we can say that our y-intercept is 0, 11. And I'm sorry if you've been struggling with this, but I just noticed that this also asks for the x-intercept, and there is a way to find that, but we are building that skill still. So you can just say in your notes that your x-intercept is currently unknown. Sorry, I didn't catch that before I built this. Okay. So your x-intercept is currently unknown, but we will have the skills to find it pretty soon. All right. Go ahead and grab your journal problems. I know this is a lot of new skills and new language. Let me know how I can help you, especially with these tables if they're tricky. There are some good Khan Academy videos that have helped me with these in the past. You guys are great. Good luck.